Continuing with the notes, what this means is that if we use the zero product property combined with our methods from chapter 8 on how to factor, we can get one side equal to 0 and then factor the other side and then use the process we just did on the previous pages to find the solutions. So let's take an approach of this one. I've got myself a quadratic equation. I can't attack that x by algebraic inverses or by adding and subtracting and dividing and all that good stuff because I've got the x squared and the x term, which don't combine. So I need another plan of attack. And so what we're going to do is we're going to factor this first. And remember, factoring is similarly called, when you have this quadratic, unfoiling. And this is what we did in chapter 8. We said, all right, if this comes from the first terms, we have to lead in x and x. If this comes from the last terms, we have two choices, 15 and 1 or 5 and 3. And we know that 5 and 3 are our correct choices because they add up to 8. And that's a nice, easy one to factor. Now, our goal is to get the solutions. We're going to use factoring to find the solution. So be careful here because one of the most common mistakes with these is kids quit when they're done factoring because you feel like you're done. Because in chapter 8, you were done after it was factored. But we want to know what x values give us a 0 out. What are the solutions? So we set each factor equal to 0 and we solve it. Now this one, again, you could do with common sense, but just so you see the process, I set each piece equal to 0 because if two things multiplied equal 0, one or the other must be 0, which means by subtracting 5, x could be negative 5 or x could be negative 3. So these are called my solutions. If I were to plug them in here and use my calculator or my arithmetic, when I plug them in, a 0 will come out. If I were to graph that one on my graphing calculator, what it means is that it hits the x-axis at negative 5 and at 3. Also, because it leads in a 1, I know it opens up. It would look something like that, but not exactly like that because I just sketched it. So let's apply this process to these down here. I want to know what would give me a 0 out. I can't attack that m because it's m squared here and m here, so I can't combine them. So I have to use the factoring method. I'm going to unfoil. I have to lead in m times m. I can end in 7 and 2 or 14 and 1. I know one of them has to be negative. I know they have to add up to negative 5, which means my selection is, and hopefully the factoring is fresh in your head. Move that over a little bit because it's not that part over. Forget it. Anyway, I was running into the next problem, but I've got my m minus 7 and my m plus 2. That has to equal 0. I'll just put the 0 over here. What that means is either this is 0 or this factor is 0. So consequently, m could be a 7, because 7 minus 7 is 0. M could be a negative 2, because negative 2 plus 2 is 0. And I've got two solutions. Had I graphed it, it would have hit the x-axis twice, at 7 and at negative 2. So the next one up, again, I am unfoiling. I'm going to look at my factors of 20, 20 and 1, 4 and 5, 10 and 2, try to come up with a pair that I can get a 1 out of. It would be this middle pair, as long as the 4 is negative. Now I've got a pair of numbers that multiply and can be my lasts to equal to negative 20, and they add up, or my outside plus inside will be a 1, and I will just simply factor it. So I've got p minus 4 times p plus 5, which equals 0. I need to keep going. That is factored. The solutions would be what make them 0, which would mean p would equal 4, or p could equal negative 5. There are two solutions. Again, the most common mistakes we see on this is people quit here because it's factored, but again, we want to get the solutions. Another common mistake is saying that these are your solutions, and you'll notice that they are actually not. So make sure you follow the process. You factor, set each factor equal to 0, and solve. So let's look at letter C. This one's a little harder because we lead in this 2. So what we know is we've got to be looking at 2 and 1. and how I can combine it with either 2 and 9, 3 and 6, or 18 and 1 to come up with that negative 15 in the middle. Also, a little sign analysis tells me that they need to both be negative to multiply equal positive and add up to a negative. So I know I'm dealing with two negative numbers. Now, how do I get the negative 15? Well, let's go take a look here. For time purposes, well, let's run through it. I think I'm going to save some time. If you ran through your options, like we did last chapter, you would select this pair due to the negative 12 and the negative 3, adding up to negative 15. We're going to factor it, aka unfoil it. I'm going to lead in 2a and 1a. I'm going to end in the 3, in the negative 3 and the negative 6. Be careful who you pair it with. 2 is linked with negative 6, so make sure you link it on the outside with the minus 6. And negative 3 will be in the middle. Remember, you can always check those by foiling. Now, I'm not done. It is factored. I need the solutions. What makes this equal to 0? What makes this equal to 0? This one's obvious. 6 minus 6 is equal to 0, so there's one of my solutions. My other solution would come from physically setting it equal to 0 and using my linear algebra skills, doing the opposite, to solve for a. So I'd have 2 times a is equal to 3, and I'd divide both sides by 2, and get a is equal to 3 halves, or 1 1/2. Don't lose track of what you just found. You found the values for a, that if you were to go to your calculator and do 2 times a squared minus 15 times a plus 18, you will get a 0 out. They're called the solutions to the quadratic equation. It means that if you had graphed this, you would have it hitting the x-axis, although they're using a's here instead of x's, which I don't particularly like, but that's all right. Let's go take a look at another one that we're going to do 2 ways. We're going to do it with today's method, which says to factor it first. Let's remember our number 1 rule of factoring. So we're going to pretend this is y equals kind of, and we're going to factor it. What can you pull out of both terms? And the answer to that is a 4, so we're going to factor that out. Can I go any farther with this? And the answer is yes. It's a difference of squares. So from chapter 8, we said that differences of squares unfoil or factor into same leads. X times x gives you x squared. Same lasts. 2 times 2 gives you 4. To create the O and I wipe out, 1 plus 1 minus. Keep in mind though, I want to know what makes it equal to 0. 4 can't be equal to 0, but x plus 2 can if x is equal to negative 2. X minus 2 can if x is equal, sorry, got the negative there, 2. So here's my 2 solutions. Sometimes you'll see that written as plus or minus 2. Now, is there another way to do this one? And there is, because of the lack of the b term, because there's no x term in this one, I can attack that with pure algebra, like we did in section 9.3. I can attack x. I can get rid of the 16 by adding it to both sides. I can undo the 4, or cancel the 4, by dividing both sides. I've got x squared is equal to 4. I can undo the square by square rooting. Square root of 4 is 2, and I purposely made a mistake here that's very common. If you had graphed it, you wouldn't miss both solutions, because you would see that hitting the x-axis at 2 and at negative 2, if we had graphed it on the graphing calculator, you'd see it hitting there. When you do it by factoring, it splits into its 2 pieces, so you can't miss both answers. But sometimes with this algebraic method over here, we miss the fact that it's actually plus or minus 2, because 2 squared is 4, and negative 2 squared is also 4. So sometimes that method of square roots, although it's the easiest method, first of all, it doesn't always work. Second of all, sometimes we miss a solution. So the final question is, why can't I do A, B, and C two ways. And the question, and by A, B, and C, I mean the questions up above here. And the answer to that is because there is what we call a b term, or there's a bx there. And so we can't attack that x squared by using pure algebra. So on the next page, let's go take a look here. Remember, if one side isn't equal to 0, you must get it equal to 0 first. So on this one, I've got to get this 18 out of here, which means I'm going to subtract it from both sides. I get 4x squared minus 21x minus 18 is equal to 0. Next, I'm going to factor it. Can I pull anything out of all of these terms? The answer is no. So I start my unfoiling process. I can lead in 2x and 2x, or sometimes we just put 2 and 2. Remember, there's x's there, though. 6 and 3, 9 and 2, 18 and 1, or perhaps it's 4x and 1x. I am looking for the combination that I can get a 21 out of. Now, let some science help you. I know I've got one positive and one negative. So let's begin here. Can I get it out of the first pair? And again, you can't see what I'm pointing at, but you should be used to this enough by now that I am trying to link these, and I'm getting 12 and 6, and I can't get a 21 out of those. I see it right now, so I'm not going to go through all the linking because we did that all in Chapter 8, but right here along the green path, I got a 24 with 4 times 6 and a 3. 24 and 3 will work as long as, and remember, the bigger one gets the sign of the middle. So as long as that 24 is negative, I have my proper pair selections. So let's go factor it. I have chosen to lead in 4x times 1x, and when I multiply those first terms, I get 4x squared. I have chose to end in the 6 and the 3. Be careful where you put them, follow your arc. 4 is linked with a minus 6, so make sure your 4 is on the outside, minus is also on the outside, and a plus 3 in the middle. And remember, I am not done. That's the biggest mistake here. And I'm not done because I need to find the solution. So I actually need to set each factor equal to 0 and solve it. 6 would make that one 0, I can see that. On this one, I take the 4x plus 3 and I solve it by doing the inverse operations. And I'm going to go a little fast here because I don't have much time left on my video. And I get negative 3/4. These are the solutions to the equation. So, last one up before I'm done with this video is this one. Again, I need to get it equal to 0. So in order to do that, I'm going to add that 49 to both sides, moving it over to the left and off of the right. I'm now going to factor it. Can I pull anything out of each of these? No. Is there a pair of numbers that multiply to equal 49 and add up to 14? Yes. And again, I'm not worried about what's going on out front here because it can only be x and x. I'm going to end in 7 and 7. Both will be positive. I'm not done. I need to give the solutions. What makes this factor equal 0? The answer is negative 7. What makes this factor equal 0? And the answer is also negative 7. This is what we call a double root. You don't have to list it twice. But remember, graphically, we said that the solutions are the x-intercepts of the graph, which means the graph of that related function, y equals x squared plus 14x plus 49, hits the x-axis right here. Well, how can it hit only once? And the answer to that is if it hits at its vertex. This opens up because that's a positive. So what I know is had I graphed it on my graphing calculator, it would have looked like this, hitting only once at negative 7. So what I'd like you to do before you work on the worksheet is go try 2 of them and compare them with the person next to you. Go try number 1 and go try number 3. And we don't need to do these. And then we'll work on the assignment for 9-4.